Yeah, then welcome to our session, Load Management for Charging Stations with OpenEMS. Maybe we allow a few more seconds and see whether others will join, because the last presentation took a bit longer than initially expected. But yeah, if the number is not increasing, then let's simply start. Or we have then 2 introduction slides. Maybe I start with them. And so, okay, let's start. First of all, a quick introduction of ourselves, the 2 speakers. That's Lehne and Ulrich Laupp, that's me. We are both CEOs of the opernikus GmbH, being an IT service provider for quite some years now, but a startup in the field of energy management. We moved our focus a bit the last years, and our goal is to contribute as much as possible to the transformation of the energy supply towards climate-friendly and renewable sources. We are convinced that the means of information technology, and that's the area where we come from, that these are an important building block in this regards. We rely doing so on open source software to ensure vendor independence and flexibility as much as possible. And this is one of the reasons why we also use OpenEMS. And we would like to invest our strength and knowledge in the future exclusively in projects that meet our goals and self-imposed guidelines. Let's have a look at some projects of us that you get a better picture of what we are doing with OpenEMS. That's on the one hand side, pure peak shaving. For an industrial customer, we use there a battery storage to limit the grid consumption in order to avoid expensive peaks. Then a second project that we are currently focusing is together with a hotel, where we deliver the energy management system to coordinate here the producers, the storage, and the consumers in order to increase the self-consumption for the hotel and also to avoid cost-expensive peaks. As consumers there, we have, for example, the kitchen and all, but also the charging infrastructure, which step in at the same time during the day in the evening hours. And then the last project here on the slide is then the charging park with prioritized charging sessions. This is also the project we want to focus on within this presentation. In here, we use the charging infrastructure as a flexibility to limit the grid consumption and keep it underneath a configurable threshold. But this is something that we're gonna look at later on way more in detail. I do not know the audience in here and how familiar you are with OpenEMS and its architecture. But to give you a bit of a feeling, if you are not that deep into this, about what needs to happen to make a charge point work with OpenEMS and to get the control over it, I wanted to go briefly over this slide. You have to read the picture on the right-hand side from bottom to top. At the lower tier, we have our hardware, so really the charging stations themselves. They need to be connected to the OpenEMS edge component, where a so-called bridge. This is then the physical connection and supporting here different protocols. We most of the time use Modbus TCP to connect those charging stations to the edge. Within the edge, we have then so-called components, which are representing your specific hardware and make it work. If you use an OpenEMS ready charging stations, then this component is already there out of the box within OpenEMS, and you can simply use it, switch it on. If not, then you need to develop an own component and implement the specificness of your charging station. At the end, when this step is done, we have a very generic nature, controllable or managed EVCS, which, and from this moment on, all charging stations behave the same. They have a defined set of data points, the so-called channels, that can be used to look what your charging station is doing or to also control it. And this is then done by the so-called controllers, which holds the actual business logic to do specific stuff with your charging stations to meet the goals in your specific situation. As a next step, we look at those controllers, which of those come directly out of the box with an OpenEMS implementation. First of all, there is the controller called electric vehicle charging station. If you look at this here are so-called widgets from the live view of an OpenEMS UI. This widget here represents simply a charging station, and by the help of this controller, you get control over this charging station. This is more or less for monitoring purposes. You see what the charging station is doing, and when you use this controller, switch it on, you can control it. This here is the flat view of it. I click on it, it opens the advanced view, and you see that this controller brings two different modes, a manual one and an automatically one. This manual mode allows you to set a maximum charging power and some other energy limits for your charging sessions, but also you can move this charging station into an automatic mode to use excess power for charging. And this is a controller that you use when you more or less have a single charging station and want to control it and make it behave like you want. If you have multiple charging stations, you need to use one of those cluster controllers. There are two of them. Here we have the situation in this example where we have three different charge points. And with this, for example, EVCS cluster self-consumption controller, you get then another widget. And also in this advanced view, you see how this looks like. It limits the maximum charging power of the combined electric vehicle charging stations depending on the excess power. And you can then move here the order of the charging station and give them a specific priority, how they should be charged. And the higher they are here in the list, the higher prioritized the station is at the end. So there is an order defined for those. The second one, which also comes with OpenEMS, is the EVCS cluster peak shaving. It looks pretty much the same as the other one, but it allows additional control options. It involves, on the one hand side, it looks on your grid, what is going on there per phase. It uses the storage, and also you have configurable limits how to use your storage. And based on those values, then the EVSS consumption is calculated, and it distributes this energy according to the configured prioritization. Pretty much the same. You simply, again, here the view from this live screen, and simply move then the charging stations, and then their order is changed. So this is what you can get out of the box with OpenEMS currently. More might come. And but in our specific customer project, we had a situation and requirements that we couldn't completely fulfill with what is currently offered. Here we are working for a car rental company, which is exclusively focusing on battery cars. And they have a long experience with, on the one hand side, those e-mobility cars, but also with charging stations. They have a campus where they have multiple charge points from different vendors built in. We have the situation there that the connection, the grid connection point, which is there for our charging stations, is also used by buildings. We have apartments there, offices, we have elevators and stuff like this, which is resulting in a high volatility of consumption there at the grid point. And in addition, we have producers in this environment like a PV, a hydropower plant even, and this combined heat and power generator. And I think that the hydropower plant and the CHP have managing capabilities on their own and also try to keep the grid to a certain limit. So in this complex situation, our customer asked us to build a plug-in solution which allows them to configure limits at the grid points that we need to stay underneath and use the flexibility simply of the charge points for this. And as you have seen on the other screens, the available controllers work with priorities, so an order, but they want to have the available power to be distributed equally among the charge points, what they called fair share. And the priorities should be possible to set per charging station, not per charge point. And at the end, as this all is a kind of showcase for our customer, they want to have an easy to understand visualization of the situation of their complete charging park, but also the single loading processes. Yeah, with this, we came up with a concept, and this picture wants to illustrate the approach here. For the easiness of understanding, we differentiate here between three situations according to the colors of a traffic light. We have here the green situation when we are far away from any thresholds or limits. In this situation, we allow all cars to charge however they like. When we move then into a warning area, so get closer to our defined thresholds, we limit the allowed charging power equally, like set. Like a bar, we press from top on these bars and lift or lower this limit according to whether we are closer to the green area or then really get into an area where we suspend all loading sessions, then the car park is red. And the second line down there illustrates a situation when we have set the priority for a charging sessions. So in this situation, this car here is loading with priority. That means we lower only we use this bar here just for the other charging sessions, but exclude this one here, and this can continue. Yeah, there's a bit fancy stuff underneath the hood, where also we have rules for this, but it's not necessarily on this picture. But also, even if we have prioritized loading sessions, we have a moment where we suspend all loadings, as the grid limits is always the thing that we need to keep in mind. Like I said, this is the idea behind, and to visualize the situation, we used a separate app. At the top, you see there this is coming from a simulation where we tested our controller whether it works like expected before we moved it into the production environment. Therefore, it's called simulated charge points. But the idea is also in production and later on the same. You'll see at the very top the overall status of our charge park. Currently we are yellow. That means we are in a reduced loading situation. And then you see the different charge sessions and together with their priorities. In this case, number 2 has a priority. And with a click on this star, you can enable or disable this prioritization. That's the idea behind. which looks pretty easy from its visualization perspective, but the fancy stuff is underneath the hood. And we are using Grafana, which is a graphical tool, to have a closer look on what's really going on, to debug the controller. And that's what Christian would like to give you more insights, how this all looks under the hood. Would you like to share on your own, or should I continue?
No, thanks, Uli. I would say just keep your presentation online and I tell you when to switch the slides. So thank you for your presentation. As Uli told, I just want to show some insights of the controller and the charging stations. We are working with Grafana here because OpenEMS and Grafana works really well together. It is really easy to use the OpenEMS channels and present them within Grafana. Here you see a dashboard that's specialized on the controller we are talking about. We don't need to get into the details here. It's just to show how easy it is to show these channel values. And yeah, okay. In the next 3 slides, I will show some special situations we had in a productive environment, and it makes it more clear what's happening. So in this slide, you see in the upper left diagram that all charging stations are running well. You see 3 or 4 lines. The red line is what we tell the charging stations. So it's the limitation we do, and we see that all charging stations go down at 137 and at 142. This is because we have no prioritization at the moment. Below you see we activate the prioritization at 1:44 p.m. And then we see a difference in the behavior of the charging stations. We see the blue line, this is EVCS 6, and this is the charging station we have prioritized. You see it's almost running at full power. And you see the other charging stations are going down until the minimum power they are able to work on. Yes, so we see the controller is doing its job well in case of the prioritization. Okay, Uli, can you go a slide further? Here we see another situation, and this is also a limitation of our controller. We see that there are 4 charging stations that are charging, and in the center diagram we see the grid meter, and we see that it's somewhere in the middle between the yellow and the red line. So we are in state yellow. We try to keep the grid meter power within this range. Because we are sometimes above the red line and almost in the middle between those 2 lines, all charging stations are almost at the lowest minimum. It's starting at 135. You see it's almost down. The problem here is that a minimum power is somewhere around 3 or 4 kilowatt. So we have 4 charging stations at the beginning and 3 later on. This adds to 16 kilowatt. We will add. Also, we are restricting the charging stations, and this may be too much. It will be a problem if we have 10 charging stations, each with 4 kilowatt. So the next step for the controller would be to to take some charging stations and make them offline so that we come down with the power, even in case yellow. Okay, Uli, the next slide. So here we have another limitation. In the below diagram, we see a red line and a blue line. The red line is what the controller tells to the charging station, and the blue line is what the charging station is doing. This diagram shows a Hardy-Bart charging station, and we see that there's a reaction time. So the point when we drop the power until the power is dropped is about 8 seconds. That means we can't do really hard peak shaving because we take 5 to 8 seconds to react on any disturbance. So, and in the upper diagram, you see some huge machines are running at 916, and they go up to 167 ampere. Also, we had a limit at 70 ampere. And it is not a problem for our customer because he has huge fuses, and he is more interested in the 15 minutes power and not in the current power. So that's not a problem here, but there may be other customers which may have a problem with this, and we can't handle this only with charging stations. So we would need a battery here to peak shave these situation. But fortunately, we have OpenEMS, and it is not that hard to integrate a battery. So yeah, thanks. This shows the limitations we have currently with the controller, but it also shows it's already working, and it was not much to code. So it's really good to start with OpenEMS. On that, you can start on very complex problems, and you will get a result very fast. So, Uli, I will pass to you. Thank you.
Yeah, we are a bit in a hurry. We were asked to end in time, but as we started a bit later, it's now a bit stressy. Yeah, like Christian already said, we were able to do this all with a small amount of development effort. Of course, we could base our work on existing stuff. We had a number already of charging station within OpenEMS, and this number is even growing. And yeah, it was a nice success story, I would say, with OpenEMS here, and our customer is happy. That was it for the moment. Thanks a lot for your participation, for your interest. If you are interested, we can also get in contact after this presentation slot here. And maybe a last note, if you are interested in what we are doing and maybe want to join our team, we are currently searching for persons who want to join us, work on projects that we are currently, like the ones that we currently presented. Yeah, get in contact with us. Have a nice afternoon. Bye-bye. Thank you.
Thank you.
Thank you, Christian and Ulrich. If you want, we can still answer some questions. As I said, we are a bit late, but it was not your fault. So if anyone has questions, we still have time. Yes. Or maybe if someone wants to come on the stage to ask the questions, feel free to raise your hand. We have a raised hand here. Simon, you should be on stage now.
Thank you very much. Just in case no one else asks a question, is that something that you would kind of do again in another context? I mean, it's not a technical question. I really like the stuff that you did there, but from your business model, is that something that you would offer to other companies to build up these, let's say it, microgrids?
I do not exactly understand what you mean with microgrid. So in this case, it was a project that we did with specific requirements. But out of this, I think we can use this as a plug-in solution also in other environments, maybe with small adaptations. But I think it can also be used in other environments. Does this answer your question, or what exactly are you focusing on?
I was actually asking for your let's say business model that you operate with OpenEMS. So because you set up a really complicated solution there, so is it that you're looking for big projects that you want to help customers with?
Okay, we would like to turn this specific thing here into a product, which at the end, it might be a small project to set this up, to configure this according to customer wishes. But the hope is really that you get a plug-in solution as a product that you can use with those configurable limits. And to limit the time that we use on a specific situation, but have then something flexible in place that you can easily use. So get away from project, more into a product where you can get this from us, and we take care, we monitor then the solution on customer side, take care that everything works as expected, send out notifications if something is out of order, and stuff like this. This is currently what we are working on.
Thank you very much.
Maybe to tell something about the larger context from an OpenEMS perspective, we have currently 3 companies are working on a charging station. For example, Fenecon does it with batteries. They concentrate on solutions around a battery. We try to concentrate on very easy solutions, very cost-effective solutions, I would say. But we want to work together, for example, on drivers for charging stations. It does not make sense that every company does its own implementations of charging stations. So we are discussing and we are talking who is implementing which charging stations, and we want to provide these drivers to OpenEMS so that everyone can use all these drivers and also the controllers. We are trying to work on the controllers to have different controllers for different situations, because it sounds easy to have a general product, but in real life, no customer has the same situation. So it's always a bit different, and we are currently looking for a way to find a solution to fit to most customers. Okay, any other questions? Yeah, Antonia, I would say it's your part. So if someone wants to know anything more, please contact us. We can discuss this later on.
Okay, then thank you again for your presentation. We will have a little break now of 5 minutes left. And our next presentation will be in a few minutes. Torsten and I will change. So Torsten will be here after our break and I will be in the German track. So see you soon again.
Thank you.
Thank you.
Bye-bye.
Bye-bye.